Hello, people. We are in the Bronx. I'm waiting on a little something, and I was supposed to read, but like I enjoy reading so little that like I might as well be illiterate. No, I'm not kidding. Like I only read math books. Also I'm a little tired, so I needed to catch up. But like I can't fall asleep very easily, but like, you know, I could still try, right? Anyway, book review. So on my lap is like an amazing book. I love this book so much that I have in my book reviews, like general book review, said that this is my favorite book of all time. And I really mean that. This is my favorite book of all time. Now, I, in my humble opinion, claim that this is the best math book ever written. Now, I said that like the best calculus book ever written is Michael Spivak's calculus. Yo, stop. Like, this guy, I was so scared. I'm sorry, like, he's like right there. He's like backing up. Like, I was like, and I don't even know why my honking did. Anyway, let's get back to the book review. I was so scared he was gonna hit me. Okay, anyway, like, yeah, so, I said that Michael Spivak's calculus is, like, my favorite calculus book. And so, you know, I have a good taste. That's all I'm trying to say. Now, this is not really your typical math book, because, like, if we flip, right, it's got, like, quite a lot of, like, words, right? So, it's, full of words for a math book, and the words are not really, like, you know, symbolic representation of numbers. But I also claim that it has sufficient math. It's just appropriate to describe, you know, some of these ideas verbally than symbolically. So that's all it is. But otherwise, I think, you know, like, there's sufficient math. I'm trying to flip to a page I remember. I haven't looked at it in quite a while, but I'm trying to flip to a page. I remember. That's an inside joke. So like, it's like really inside. Darn it, Christ! Like I can't say like I can't hold a book without like remembering the past. Oh man. Anyway, so like, yeah, that was a real inside joke. Sorry, I digress. But let's get back to this. There's like a spot like where I think he's talking about non-Euclidean geometries, and there's quite a lot of math in it, right? And so anyway, like what I'm trying to say is, don't be discouraged by the fact that, yeah, like the fact that like this isn't entirely a symbolical representation of the mathematics. There's sufficient mathematics in it, right? But what it is, this book, and why I love it so much is because, well, it talks about like topology and the fourth dimension, and what I think Jeffrey R. Weeks, bro, you're my hero. I love you. Like, just for writing this book, I love you. Like, yeah. Okay, so yeah, what Jeffrey R. Weeks said in the preface is that this is intended for like advanced high school math students to obviously anyone above that, right? Greater or equal to advanced high school math students. He'd written it with the intention of making it accessible to advanced high school math students. And I think, like, you know, for those of you that are in high school and a little bored and like really want to explore math and understand its malleability, right? Like, that's the one thing that most people do not get out of like the way that math is taught in high school and even in college, is just how malleable it is, right? How philosophical, how philosophically applicable math can be. So like, a lot of people think it's very rigid and strict, and it's not. Math is super malleable, and that's what you're gonna find out in this book, right? Oh shoot, I had a place held with this crazy glue, and I lost the page now, so I didn't. Oh, damn it. Okay. Okay, so like, here's like Einstein, right? Like, and it is when the opposite walls of a room are glued to make a 3 torus. the view looks like this. So this is the topological among the topological discussions. So like one thing that you end up finding out or learning, and this is just like hook you, but it's also true if you read it closely. One thing you find out is that like through reading this book and maybe like, you know, some basic prior background you have, like you could figure out how to open a fridge without opening it in the fourth dimension, that is. So you can like learn how to open a fridge without opening it. So you can take out something from a fridge without opening it. And it's not, I'm not being hyperbolic. You could do that in the fourth dimension. Okay. So maybe I'll make a video in the future of precisely why, if I get back to reading this book closely. But yeah, so what is this? On a flat torus, a biplane pilot. So it's like flat manifolds is the chapter that this is on. Yeah, so this is like, I cannot talk enough about it. Like, you know, I wanted to make this book review like maybe like 3 weeks ago, but then I felt like, you know, I was not in the mood to do the book justice and like to you know to accurately like capture how committed I am to like loving this book, and you know, also like, you know, like yeah like articulating it in a way that shows just how much I love it. Okay, so this is like playing a game of tic-tac-toe on a torus or something. I don't remember. Like, but yeah, read this book, and like, and he starts with Flatland, by the way, which is like a movie that like that's, you know, mathematical, and that like my colleagues really loved. Like 2 colleagues that I really respected, like, you know, were once in our department talking about it, and they expressed their passion for me, like you know, it's about like, you know, understanding like the multiple dimensionality of like, I don't know if you'll say reality, definitely reality for me, but you know, like it's basically like learning about like how to imagine other dimensions. So what like other dimensions look like for a person living on a flat land, right? So that's what Flatland is about. And like 2 of the colleagues that I had like really loved it and talked very passionately, and like you could just see it on their face. But I never really read it or watched the movie because I like, you know, I felt like Matthew Dina's video on the fourth dimension. It's on YouTube. I found it on YouTube. Matthew Dina, the fourth dimension. His video, like, I feel like was a better version and a succinct summary of what I imagined Flatland to be. So I just watched Matthew Dina's 15-minute video. I recommend it highly. Probably more than any other video on YouTube. I think it's like the coolest video on all of YouTube. Matthew Dina's fourth dimension. Okay, but yeah, like let's look at the table of contents so that, you know, y'all are like, yeah, okay, so I get why this guy likes this book so much. So he starts with, you know, a brief mention of Flatland, the movie, and goes on talk about some topological ideas, and yeah, so this is the rest of the, you know, table of contents. And yeah, I, you know, can't say enough, but I'll have to end this video at some point, so I'll end it here. I give this book like 11 out of 10. My favorite book ever, like in the history of time. And obviously I haven't read like, you know, every book, but so this is a tad bit personal, but it's definitely my favorite book. And yeah, I recommend it like incredibly highly. Like it's worth your money. I don't know what you spend your money on, but yeah, it was definitely like no hesitation when I bought this book, and I bought it recently. I held a copy which I lost, and or I don't know where it is, and I got that for free from my school, but I had no hesitation like of spending money on this book. Yeah, okay, cool. I hope you enjoyed this, and yeah, take care.